Okay, hello everybody. My name is Kuassi as presented, and I will be joined shortly by my colleague Herman. And so this is our safe harbor. You know, if we say we talked about future functionalities, might happen, might not happen, so we are covered. This is the agenda. I will cover part one, which covers, modern container-based platform for application development, polyglot persistence, the Oracle database operator for Kubernetes, and the Oracle database operator for Kubernetes in DevOps CI/CD pipelines. And then I will talk a little bit about the roadmap. Then my colleague will take over to give you a very, very, very nice demo. You don't want to miss that demo. It's a long demo and very good one. Okay, so here we go. A modern container-based platform for application development. So what do you need? And what do we offer? Right, this is the Oracle Cloud infrastructure. And you can see from the left to the right, I'm looking at the top of the slide, you can see all the main microservices frameworks, the Micronaut, Helidon, Spring, which is the elephant, and also Java, of course, and GraalVM for native image. Then in the middle, you have all the DevOps tools that you can need, and GitHub, Jenkins, DevOps, etc., etc. Then on the right, as we're always speaking at the top of the slide, you have all the runtime. You have the API gateway, the load balancer, etc., etc. You have the application runtime, the OKE, the container engine for Kubernetes that we're calling OKE, Oracle functions. We also support low code where you can use the application express. It's a declarative programming. And then in terms of persistence, you have the autonomous transaction processing database, the autonomous data warehouse, Oracle Analytics, and different storages such as the block storage, the object storage, etc., etc. Then at the bottom of the slide, you have all the services, all the quality of services, such as the security and government. You have all the services that you will need, the Vault, the VCN, identity, etc., etc. And then you have all the observability and management services, such as logging, monitoring, etc., etc. In summary, we give you everything you will need to build a cloud native application and deploy. Next slide. Jeez, what is happening? Next slide. Okay, now I'm going to talk about polyglot persistence. So you build your cloud native application, but an application without persistence is a toy, right? You need a storage, you need persistence. Okay, so what is polyglot persistence? A cloud native application, look at the Amazon catalog, for example, you need multiple data models, not just relational. You need the image, you need graph, you need JSON, you need all sort of data models. So that's polyglot persistence. To address polyglot persistence, there are two approaches or two technologies. There are the proponent of single model engine. For example, you would need a MongoDB for JSON, you would need a Postgres for relational, or Oracle, by the way. You will need a Neo4j for graph. So you have a collection of specialized engine, and each engine does well one thing. It manages well one data model. But the problem with that is if you need to build a rich catalog, as I was referring to the Amazon catalog, for instance, you need multiple, you need all those engines side by side, right? You need all those, which means you have a plethora of SQL dialect, because even though SQL is a standard, each vendor has an extension, each vendor extends SQL. So you have different dialects. And what about monitoring? What about cross data models query? Can you issue a query across different data models, right? So there are a lot of issues with the single model approach. And that's not the Oracle approach. The Oracle approach is what is known as multimodal polyglot persistence, What does it mean? It means with the single engine, and we are not the only one, but there are very few vendors doing the multimodal approach. It means in the single engine, we can give you a JSON storage if that's what you need. We can support graph date model. We can support relational. We can support all the date models that you would need. So the benefit of supporting natively all the data models with the same engine is I can do cross-model query, okay? I can manage everything with a single operator. I don't need a multiple operator to manage all those. This is what we call the converged database. I can do distributed transaction using Saga in the database. So Saga support in the database. A Saga is a distributed transaction. For example, you book a flight, you need the flight, you need the hotel, you need the car. If one of those fail, you cancel the whole trip. But each of those is a specialized transaction, is a specific transaction, right? And you commit that transaction. But later on, you want to have the ability to revert the entire distributed transaction. That's called Saga, or long-running action in the Eclipse balance. So we support Saga in the database with very little programming. For microservices, programming is 80% of the code. So if you remove 80% of the code, it makes your life as a developer easier. So that's the benefit of the Oracle Autonomous Database. And to give you a sort of quick to remember, converged database. So Oracle Autonomous is a converged database, plus it's a cloud native, and it has machine learning. So that's what Oracle Autonomous Database gives you. It's fully automated and fully managed for any workload. Okay, that gives you a very brief summary of the OCI platform and the Oracle Autonomous Database. Now let's switch to the Oracle Database Operator for Kubernetes. We also call it OraOperator. So why do we need an operator? Well, because we want to make the Oracle database natively part of the Kubernetes infrastructure. So Kubernetes is now pervasive. You know, you have a Kubernetes operator for everything, any piece of software. So we want to make Oracle database natively part of the Kubernetes infrastructure, which will allow application developers and DBAs to integrate the database as part of the CI/CD DevOps CI/CD pipelines. We also want to provide these capabilities wherever you deploy the Oracle database, either in the Kubernetes cluster, that's containerized, so you can containerize databases, you know, Docker images can be deployed in Kubernetes cluster, or in the cloud. It can be in the cloud, in the Oracle Cloud Infrastructure, for example, we will support you, or on premises. If your database is on premises, we will also support that with the operator. So that's our goal. So how do we do that? In order to understand how we do that, let's look at a Kubernetes cluster. Natively, you know, when you deploy a Kubernetes cluster, it comes with built-in objects and controllers. Those are listed on the slide. I'm not gonna go into each of those, but those are the services and objects that you have. They are built into the Kubernetes cluster. So two things to notice here. One is the Kube API server, which is here, the API server, and you interact with the API server through a document that's called YAML. It's just a file. It's a human readable file where you specify what you want, right? You can say, I want 2 pods, and I want you know, this service, and I want that service. So every time a Kubernetes will monitor, it will monitor by using a controller. The controller will monitor the objects and make sure that they meet the specification, what you have declared. For example, you want 2 pods and 1 failed, it will launch the second pod to make sure to meet the 2 pods that you have asked for, right? So it's done through what is called a reconciliation loop. not gonna go into the details. So this is a Kubernetes cluster. Okay, now how do we make sure we can also manage Oracle databases? So to do that, let me use an abstract image. So this abstract image, you see different shapes here. Okay, imagine those are different Oracle databases deployment. Okay, so this is the API server. An operator is an extension of the API server. An extension meaning you are asking Kubernetes to manage non-native objects as its native object. And the only way you can do that is by providing an operator. An operator has controllers. Each controller knows how to operate a specific custom object, right? So the controller will do the reconciliation loop with monitor the object. And if the object does not meet the specification you have defined in the YAML file, it will adjust. So we are still using the YAML. We are still using the Kubernetes model, the Kubernetes command, but we just bring in new objects and new controllers. So this is the operator. And in a concrete term, I'm gonna move from abstract to concrete. In a concrete term, this is the Oracle database operator for Kubernetes, and this is you. And through the YAML, you can deploy the operator by use kubectl apply, and the name of the file is Oracle database operator.yaml. This is all on our GitHub page, so you will see the steps. There are 2 steps, easy steps to deploy the operator. So once the operator is deployed, it has all the controllers, the built-in controllers. Remember, no, not the built-in, but the user, the one we as Oracle has built for you for our databases. So we support containerized databases. Those run in the Kubernetes cluster. Those are Podman or Docker images, and the Kubernetes cluster can orchestrate them. So those are single instance database, sharding databases. We're also looking at RAC, containerized RAC support by the operator in the future. And for those who are running within the cluster, we don't need the REST API. We just use the Kubernetes controller runtime APIs and Oracle database commands known as DBCA. Right, so those are things running within the Kubernetes cluster. We are working on an observability controller, but that's not there today. Okay, then we have the autonomous database. For that one, we have a specific controller, and we use the OCI REST APIs to reach out to the autonomous controller. And this is a very important point. For example, if the autonomous database is running on the OCI, the Oracle Cloud Infrastructure, and your Kubernetes cluster is running on a third-party cluster, such as Azure and AWS, through the OCI REST APIs, the operator can manage the autonomous database running in OCI. Okay, of course, if it's running here within the OCI, that's no problem. It's the same thing, right? Same thing for BaseDB. BaseDB is the new name for VMDB. It's a VM-based database. You just have a compute instance. You deploy the database, and you can manage it, put whatever you want inside. So this is also run by a controller through the OCI REST APIs. Now, if your database is on premises, for example, PDB, CDB, PDB-based database, such as Exadata and things like that, we use the ORDS as the REST service to access this database, to manage the database, right? So the controller will use ORDS to manage it, okay? So that's in picture, the Oracle database operator for Kubernetes. Now, in terms of APIs, right? So in terms of APIs, in terms of lifecycle, sorry, the operator only manages and automates lifecycle of Oracle databases. So here we have the single instance database, and you can see the lifecycle operation. That's the operator offers or supports, right? And then we have data guard in preview. Preview means it's not a production. So this is the version 1.0.0, the current version, and this is a production version. So some features are not production. For example, data guard is in preview mode. Okay. Then we also support sharded database, and you can see all the life cycles operation you can do with sharded databases running within the Kubernetes cluster. Now, outside of the Kubernetes cluster, but still on OCI, we support the autonomous database, of course, provision, bind, start, stop, etc., base DB. And on premises, we support bind to CDB, create PDB, plug PDB, blah, 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 blah. So you got the picture, right? All the life cycle of a pluggable database is supported. So that's in a nutshell the Oracle database operator for Kubernetes and the kind of databases we support and the kind of lifecycle operations we support. Okay, this is an example of a YAML file, and this YAML file will bind an existing database into the operator. It will make it known by the operator. So later on, you can have another YAML file to say, oh, delete, or increase the CPU or things like that. Okay, I'm not gonna go into the detail. You can. It's easy to read, right? You have the specification here, and according to the tabulation, you can see those are the details. You know, the name and the secret. The secret are things where you hide your password, things like that. You can also hide them in wallet. Is also put in a secret, etc., etc. Okay. Now let's talk about, and this is the last part of my presentation, which is how do you fold the Oracle database operator for Kubernetes in your DevOps CI/CD pipeline? Okay, these are problems or issues that putting the operator in your DevOps will address for you. For example, developers, they are not DBAs. And they don't want to wait for a DBA in order to provision quickly a database for the dev and test. You don't want to do that, right? You want to run a script, or integrate in your DevOps CI/CD pipelines, and then it's gonna provision a database for you. If you need to delete, it's gonna delete for you, etc., etc. Same thing for DBAs. DBAs, they don't want to be there to be manually applying schema changes or things like that. So those are sort of issues that putting or folding the operator in your CI/CD DevOps pipelines will address. And in a very minimalist illustration, we have Mr. Jenkins in the middle here. So, which is one of the tools you use in DevOps, right? So I want to create a branch. Mr. Jenkins will generate the YAML file and execute it. So the operator will execute the YAML file and will provision the database for you. So that's an automation, right? We don't need to manually issue kubectl, blah, blah, blah. Mr. Jenkins will do that for us. Similarly, I want to delete a branch. Mr. Jenkins will generate a YAML file, which will be executed to delete the database. And then you can push your branch, for build and test and things like that. Okay, so that's a very simplistic representation of how you can incorporate the operator into your CI/CD pipeline. What we are looking at in the future is to integrate schema changes frameworks such as Liquibase or Flyway. It's not there yet, but we are looking into it. Okay, in terms of roadmap, so as I just said, we are looking at incorporating the operator into DevOps CI/CD pipelines and support for schema changes or schema change management tools. We are going to have a rack controller. So a rack will be containerized and deployed within the Kubernetes cluster. So for that, we need a controller. You know now how the operator works, right? You need a controller for a new thing. If we bring any new database shape, we're going to have a controller, and that's it. It's going to support it. It's going to work for it. So the operator is extensible, so we can add controllers at will. Certification OpenShift, we know that many customers are using OpenShift. So we have certified the previous release, but not this one. So we are looking into certification for OpenShift. And workflow deployment integration on OKE. On the OKE console, you will have the ability to just push on the button and the operator will be installed, and even some database is provisioned for you. For example, autonomous database or single instance database. Publishing the operator on operatorhub.io, we know that this is the place where most developers get the operators, so we're looking into that. And by the consequence, support the operator lifecycle manager. And testing on other major Kubernetes distributors. As I said, this operator has been successfully tested working on Azure and AWS. We're looking into testing some other. And this is where I hand over to my colleague. I'm going to stop sharing and Herman will take over.
Okay, thank you, Kuassi. That was a great presentation. Thank you for all the introduction to OraOperator. Now let's take a closer look at the demo to see all of this in action. So let me share my screen. You should see like demo prerequisites. I hope you're seeing that right now. So basically what I'm going to do is I'm going to go through lab 2 of the Oracle Database Operator for Kubernetes plus DevOps. This is a really nice live lab. I recommend you go through it. There's a short link there in the top right. So what I did before, because we don't have time to do the whole live lab, I did lab 1, which is basically create a Kubernetes cluster. Okay, so I've set up a Kubernetes cluster. I'm using OKE within OCI. I created all the API keys. I basically set up the cluster, but the cluster is empty. It doesn't have the OraOperator. It doesn't have cert management. It doesn't have anything. Basically, it's an initialized cluster with a notebook. Okay, so to give you an idea what we're going to do, and I will have to go a little bit fast because we have a lot of things to show. I think they are very interesting. That it's very interesting that we cover, you know, multiple aspects of the OraOperator, but please feel free to watch the recording later, maybe pause, etc., etc. Okay, so I'm going to go through lab 2. I'm going to install and configure the OraOperator. I'm going to install Cert Manager and the OraOperator. Cert Manager is a prerequisite for the OraOperator. I'm going to set up all the credentials, all the secrets, like Kuassi already mentioned. Okay, I'm going to generate a YAML for the creation of an ADB. We're going to create an autonomous database through the operator. We're going to generate, there's a typo there, we're going to generate the ADB wallet, okay, create the secret, the YAML, and apply it so we can manage the wallet via the OraOperator. That's really nice. We are going to initialize the ADB for use with CloudBank. So the microservices running on top of in this slide for the demo are basically the CloudBank microservice, which is very simple. It's transferring money from bank A account to bank B account. So it's super, super simple. I don't think we will have time to actually deploy the full-blown microservice on top, but basically the focus is OraOperator, it's not the microservice. Okay, so we are going to scale ADB with the OraOperator, and this is really, really nice to see it in action. And also we're going to finally extract the wallet locally and connect to ADB to run some queries. So you basically understand how OraOperator can help you ultimately connect to the database. Okay, I don't think we'll have time to do the last part, which is build and deploy CloudBank over the provision ADB, but that's basically a script that creates the 2 microservices on top of ADB. Okay, so let me switch to the OCI console. Okay, and here you will see that I do have a cluster. Okay, it's called CloudBank, and what I did is I went to developer tools and Cloud Shell here. I'm going to restart the session, and this is basically you know, a command line that you have here, which is pre-configured to connect to OCI. So you have you can run any OCI CLI command here, and what I did is I basically passed the configuration to connect to be able to connect to the cluster. When you have a cluster, you can go to the cluster, you can click on a connect command, and it will give you just a command line that you can paste here, and you are up and running to connect to the cluster. Okay, so to give you an idea, I'm going to do kubectl get nodes. I'm going to go full screen and then I'm going to come back. Okay, so these are the nodes that I have. I'm going to show you the via kubectl the namespaces. Okay, so these are the namespaces that I have. So it's, as you can see, I have the kube system up and running, but I don't have any extra stuff here. So I'm going to show you the Cloud1 namespace, and you will see that we are basically empty. Okay, so we're starting from a very basic cluster, which is ready to install the operator. So first of all, what we're going to do is we are going to install Cert Manager, which is a prerequisite. Okay, so let's do that. We use kubectl apply, and we just go to the Cert Manager page. So if you don't do that, you will not be able to run OraOperator. So before starting OraOperator, we install Cert Manager. Now I'm going to go and I'm going to verify that Cert Manager is up and running. So the way we can do that is we can get the deploy for the namespace Cert Manager, and you can see that this is ready. Cert Manager should show 3 items there, and you should see 1.1. So we are ready to install the operator, and the operator is just, applying a YAML that we get from the project, from the OraOperator project. I'm going to show it here. As you can see, I'm applying the Oracle Database Operator YAML, and it's installed, right? So very, very easy to put OraOperator in your cluster. So basically, it's there. Now, let's take a closer look. Let's verify what we just did. So if I do this and I get the pods, you will see that they are ready, right? This is the controller manager, and it's ready and it's running, right? So if I take a closer look like this, like if I do a get all instead of get pods, okay. So you will see that we have a specific, private IPs, ports, etc. for the service. We have the webhook services, the controller manager, management metrics service, etc., etc. So we seem to be good. We seem to be up and running. Now, how is OraOperator extending the Kubernetes API? You can do this, and you can check out the API resources for the group database.oracle.com, and you will see that we have, this new kinds where you have the ability to manage autonomous container databases, autonomous database backup, restore, autonomous database, CDBs, single instance databases, sharding database, all the support that Kuassi mentioned during his session. Okay. So let's prepare things for ADB creation. So I'm going to create a config map here, which is a set of info and credentials so OraOperator can connect to OCI, okay? So remember that Kuassi mentioned that OraOperator works with OCI. So if you want to work with OCI, you need to know what the tenancy ID is, what the user is, what the fingerprint for the API key is, region identifier, etc. So I just created a config map within the Kubernetes cluster with all this information. Now what I'm going to do is I'm going to create a secret pointing to the private key of the API key. So let me just do that. We have to manage just a few secrets, okay? If you do lab1, you will see that these variables that you will see here have been previously set. So in lab1, you set up a whole bunch of environment variables, etc., with some credentials, etc., but you don't place that within secrets in the OraOperator, in the cluster. So that's what I'm doing right now. Okay. So this is no OCI private key for the the API key that allows me to connect to OCI. Okay. So I'm going to create the OCI admin password. Okay. This is the admin password for the database, right? And I'm going to put it as a secret in the cluster. Okay, so we have set these credentials when we created lab1. Basically, there was a script that was asking, oh, what's the password for the database? It was collecting that information. We're just taking back that information and putting them as secrets within the cluster. Okay, So what I'm going to do, I'm going to generate just a script here that allows me to generate the YAML for ADB, and we're going to take a closer look at it. So this is right now creating a YAML for us for ADB creation. So let's take a closer look at that YAML before we apply it. Okay, let me see. A sec. I need to actually do nano and this because I'm not in that directory. Just one sec. Okay. So here you can see that we are operating in the Cloud One namespace. We're passing the compartment OCID. I'm working in a compartment called Kubernetes compartment. We are providing a DB name, a display name, and we're saying, hey, I want one CPU, right? I want one terabyte as data storage. This is the admin password for the database, which is stored in a secret. And this is my config map to connect to OCI, because we'll have to order OCI to say to actually create that database. Okay, so I'm going to exit. Let me see if I can do this. Okay. Now I'm going to apply it. Right. I'm just going to run this command here. And what I'm going to do is I'm going to go to autonomous here, right? And I'm going to show you live what's happening. So this just wasn't here, just appeared, and it's in a provisioning state. So basically we know that this creation is working because it is provisioning right now. So we are provisioning an autonomous database serverless. Usually that takes around 2 minutes to give you an idea. So let's keep it provisioning. But in the meantime, okay, what we can do is verify what's going on. So for example, if we do this, like kubectl get autonomous database, we see that we have a database that is in the provisioning state, and we did that all via the operator, right? And we can describe also the Cloud Bank DB. Let me see if I can describe it while it's in the provisioning state. Yeah, you can see it is in the provisioning state. And if you take a look at the describe, you will see that it's basically giving me the OCID for the database, you know, the fact that it's an OLTP, so an ATP, et cetera, But once it's provisioned, this describe command will also give me the connection strings for the database, which I think it is very interesting, okay? So we are going to wait until this is provisioned. So let's take a closer look here. Now it's available, you see, just change. And now if we do get autonomous database, we see that the state it's available here, okay? So we can proceed now. What we are going to do is we are going to create a secret, the password for the DB instance wallet that we will use. So we want a wallet, right? And if you are familiar with the process of creating a wallet, when you go and do that manually within OCI, you basically have to provide a password, right? So we are going to do that, but we are going to pass it to the cluster, okay, as a secret. So I'm creating a secret, which is the instance wallet password, okay? Okay, so that is created, perfect. And now what I'm going to do is I want to create that wallet, or basically generate the wallet on the OCI side using OraOperator, okay? So I'm going to ask this live lab, basically this live lab has a script that generates that YAML for me. And now we're going to take a closer look, okay, at that YAML. Okay, so let's do nano. Okay. All right. So so as you can see, we passed the autonomous database OCID. We say that we want an instance wallet, and we pass the password for that instance wallet. We are also passing the OCI configuration, which is basically connection. Okay, so we are going to exit. Let's see. Okay, oh, we are going to just apply this, which is the recommended command over there. Okay. All right. So I'm applying that, and that's it. I don't have to do anything related to the wallet. Basically, the wallet is being generated for me. Here we have like an issue with the visibility, but I think that this is just a refresh issue. Okay. So let me go back. Yeah, there you go. All right. So wallet issue solved, right? Okay. So let's verify that we have the wallet. So as you can see, we have the instance wallet and the instance wallet password. We created the password, but now we have the instance wallet, okay, which is the wallet itself. So we're going to initialize ADB for use with the CloudBank microservices. So we need users in the database, we need grants, we need schemas, we need tables, etc., etc. So I'm going to init the database. There is a script that basically does that for me. Sorry, not Nano. I'm going to I want to show it, but I just want to run it. So there you go. Initializing autonomous database. This is basically connecting to the database and creating the grants, etc. It's also downloading the wallet to connect to the database. Okay. All right. So let's take a look at some of the logs when this is done about what happened. So if I do nano logs, let's go to cdc logs. And let's take a look at the SQL log, which is 6. Yeah. Okay. So you will see that I basically created users, provided grants. Okay. Grants succeeded, etc., etc. Routes inserted. I created a table. I created a bank user accounts, bank B user accounts. So these are all the setup that is needed within the database to make the microservices work. Okay. So I'm going to exit now. Okay. Perfect. And what I'm going to do is I'm going to show you a scaling exercise. We have this autonomous database, and I want to scale it. Okay. So I have this scaling. We have this scaling YAML that I created. I'm going to show it to you now, where I basically say I'm going to operate over an autonomous database. I'm in the CloudBank namespace. This is the OCID of my database. So here we need to actually place the current OCID of the database, because this is from a previous run. And I want to go, the CPU core count, I want to go up to 2, and the database storage, I want to go up to 2, okay? And that's it. That's the YAML for doing the scaling. I'm going to just update the OCID. So let me fetch that. Again, in autonomous database. So I will do a describe to get the OCID because we don't get it there. So let me do a describe. Okay. As you can see, now we have the connection strings here. Now that the database has been provisioned, and I'm going to copy the OCID. This can, of course, be automated. We are doing like manual scaling process using the operator. So now I'm going to edit the scale ADB, and now I'm going to delete the OCID, and I'm going to place the okay. This is my OCID. I'm going to save, I have my YAML, and now I'm going to take a look at the database, and I'm going to apply this YAML. Okay, let's try to scale it. There you go. Okay, it says configure, and you probably saw here that now it says scaling in progress. So this is just going up now to 2 OCPUs and 2 terabytes of storage. We're going to wait for that to happen, because I want to show you how to scale down using a different approach, which is basically patching the spec. If you've been paying attention, you probably heard Kuassi saying that we are operating over a spec. So we have a spec that the OraOperator tries to maintain, right? And this is typical, of operators, if you're familiar with, operators in Kubernetes clusters. So if we patch the spec to make it go back to 1 OCPU on 1 terabyte, OraOperator would just accommodate the system to the spec. Okay, so let's see if we scale finally. Just give me 1 sec. Let's try to describe again and see. There you can see scale in progress. Okay, and if we do describe, we will see the same thing. All right, we see scale in progress here. Let's wait a little bit. Let me see if I can keep going with other. There you go, available. Okay, so we have 2 OCPUs, 2 terabytes. Okay, great. So scale operation worked great, and we can just take a closer look now. I will say available 2 OCPUs, 2 terabytes of storage. So as I said, let's patch the spec to make it go back to 1 OCPU on 1 terabyte. And all I have to do is this: kubectl patch autonomous database in the CloudBank namespace -p, and I'm basically patching the spec, and I'm saying the details in the spec. I want the CPU core count to go back to 1, data storage size in terabytes to go back to 1, and I want to merge this information into the current spec. Okay, so I'm hitting enter now. Okay, so it has been patched, and we should see that it's scaling soon. There you go, scaling in progress, 2 CPUs, 2 terabytes, and now I'm trying to scale back. Okay, scaling in progress. Okay, so you can also apply, you can also edit the file. For example, the one that I showed before, you can edit this file, replace the number 2s with number 1s, apply the YAML, and you can have the same effect. Okay, all right. So what I'm going to do right now is I'm going to extract the wallet. So suppose that I want the wallet local, because I want to start playing with the database to my own connection. So I created this script that basically allows me to source to extract the wallet locally. Okay, so I'm going to do that. Let's wait. I'm not sure if this is affected by the scaling process. I don't think so. But if you do nano here, you can see that this script is basically bringing the TS names Ora, SQLnet Ora, cWallet, SSO, eWallet. It's basically bringing the wallet locally. And this is being extracted from the secrets in the kubectl, as you can see. But this is the way in which you can actually do that, right? Okay, so this is what we just did. And we are almost done here. We are good with time. So just let me go back. Okay, perfect. And now we can just do use SQLCL or SQL Plus to connect. For example, if I do just let me list the, if I do this, SQL plus admin at, and the name of the database. We're asked for a password. And here there is a bug in the live lab. So let me be very clear about this. When you set up lab 1, this live lab, you are asked to provision a password. So you say this is going to be the password. So the password right now for this provision database should be the one that you provided, but I don't know why this is failing and it's basically using a default password. There's probably a bug in the live lab that I need to take a closer look at. So the password is set to welcome 12345, okay, in the live lab. So if you struggle and if you cannot log in and you say, hey, but I provided this password and I'm putting this password and it's not working, try welcome 12345 with the W in the welcome in capitals, okay? So I'm going to do that. Welcome 12345. We have a problem here. Let me see. Okay, let's try again. One, two, three, four, five. Oh, I don't know why I cannot resolve it. Yeah. So let me see. But the problem that I mentioned is real. Okay. So keep an eye on that. So let me see. Oh, I think I'm missing the. Yeah, I'm missing something. One sec. Let's solve that. What I'm missing is this. For example, we could connect to medium. So you need to provide, actually, you could use high there, etc. Okay, so let's do welcome 1, 2, 3, 4, 5. Okay, and there you go. We are in. So right now I could do like a select from all users, and you can see that I have bank a user, etc. Those are the users that we created when we run that script that I showed you before, that was basically setting up the database for the Cloud One application. So we can basically ask for all tables for bank A users, and we have the accounts table, okay? And we can do like a select in that table, and you will see that we have account IDs, account values. So basically this is money that you have on specific account IDs, and when you provision the UI, you can move money, and you can come and see how the money is being moved. Okay, there. So unfortunately, I don't have time to show how to deploy the app, but I think I showed here. You can do exit or quit. I think I showed everything that I wanted to show in terms of the operators. So Violeta, we can go to questions now, if you think that's okay, or to
Yes,
the resources.
I think Kwasi already answered them all, Herman. So I would proceed with the useful resources now. But with that, we can just close the call. Thank you all for attending this session. Thank you, Kwasi and Herman, for delivering to us again a great
Thank
session
you.
and demo. We hope to
Thank
see
you.
you soon again here at Cloud Coaching. We
Thank
hope
you.
that our customers enjoyed the session and learned the great things that you showed today. And of course, we hope to see you to see everyone soon. Thank you and enjoy the rest of the day. Bye bye.
Bye.